Hello everyone, I'm Zhao Wenju, and this is our team from School of Teaching and Learning at the University of Florida. This presentation is a funded project about comparing multimedia learning outcomes, satisfaction, and mental effort between college students with and without dyslexia. With the development of online learning, there are chances to use multimedia in this field. The common sense is multimedia will enhance online learning. However, does multimedia learning apply to the population in the same way? Does multimedia learning hold true for all learners? The reality is the multimedia learning principles and cognitive theory of multimedia learning has already been widely tested using typical college students, but there is limited to research focused on disabilities or individual differences, and little research focused on how dyslexic college students learn in general, especially few research studies on comparing typical students with dyslexic students under multimedia circumstances. The situation is that we easily overlook students with special needs. Data shows about 85% of students with learning disabilities have some forms of dyslexia. Many more people, perhaps as many as 15 to 20% of the population as a whole, have some of the symptoms of dyslexia. However, the translation of basic science research into improved methods for the instruction of individuals with dyslexia is very limited. The gap in knowledge regarding the efficacy of instructional strategies for optimizing learning for students with dyslexia is especially great with regards to the use of multimedia instruction as identified by the augmented of text through listening and graphic representations. And this study focused on examining the effects of multimedia learning principles and modality principle on learning performance, satisfaction, and self-reported mental effort score among college students with and without dyslexia. This is our research questions. This study utilized a multimedia intervention entitled Discovering Australia, which has been validated in previous multimedia studies. In total, 148 participants has been included in this study, with 73 students with dyslexia and 75 without dyslexia. These participants has been systematically assigned to one of the four conditions: text and picture present conditions and text and picture absent condition, narration and picture present and narration picture absent conditions. We conducted a three-way factorial design using dyslexia, multimedia, and modality as the independent variables and learning outcomes, satisfaction, and mental effort as the dependent of variables. For measuring learners' learning outcomes, we designed to ask them cue recall questions at first, and then with the same 20 multiple choices questions. During the intervention, the content of each slide include two related questions in measures of retention. There are 20 cued recall questions and the 20 same recognition questions. Here are the sample questions. Here are the satisfaction questions and the self-reported mental effort questions. All these questions have been validated in previous studies. All data were exported from the intervention to an Excel spreadsheet to track the missingness. Then the data was exported to SPSS for analysis. A series of ANOVA procedures were conducted with post hoc follow-up when significant differences were found. We found that in Q recall questions, overall there is no difference between two groups of learners, and there is no significant three-way interaction among dyslexia, modality, and multimedia. However, there is a significant two-way interaction between dyslexia and modality, and in post-hoc results, students with dyslexia performed better than non-dyslexic students in text-based conditions, especially in text-to-picture present conditions. In recognition questions, overall there is no difference between two groups of learners, and there is also no significant three-way interaction among dyslexia, multimedia, and modality. However, there are a significant two-way interaction between dyslexia and modality. And in the post-hoc results, students without dyslexia performed better than dyslexic students in picture absent conditions and narration conditions. In the satisfaction aspect, students without dyslexia reported higher satisfaction than students with dyslexia in narration conditions, especially in narration and picture absent conditions. In self-reported mental effort scores, students with dyslexia reported higher mental effort score than students without dyslexia in picture-based conditions and narration conditions. Actually, in terms of the multimedia principle, cue recall items are considered more difficult than cognition items, but students with dyslexia performed better than those without dyslexia on cue recall items in text-based conditions. This may be explained using compensation strategies that our participants are students with dyslexia who already studied at the university levels and has already developed the ability that significantly correlated to reading ability. However, in recognition questions, students with dyslexia did not perform better in text-based conditions compared with students without dyslexia, and the students with dyslexia reported higher mental effort scores. This may be explained that we ask recognition questions after cue recall questions, and at that time students with dyslexia has already been tired and lost focus. Students with dyslexia may have the desire to perform as better as they can to prove their academic ability, but these strong will may not be able to support them to maintain high concentration for a long time. Besides, we selected the representational pictures aligned to the content. The results may be different if we change the types of image. Since that we found this in this study somewhat conflicting with other studies regarding pictures, it still needs to be examined whether the multimedia principles support learning for students with dyslexia. For modality principles, students without dyslexia performed better than students with dyslexia in both narration conditions for cue recall and recognition questions. And at the same time, students without dyslexia reported higher satisfaction score than students with dyslexia and lower mental effort score. It seems that college students with dyslexia struggled in narration conditions in this study. In the current study, it is reasonable to speculate that the reverse modality effect was due to the transient information effect imposed by the length of text in each passage. It is likely that learners have difficulties adequately processing the spoken text before it disappeared, thus causing the modality effect to be reversed, similar to Levy and Sweller and Wong and Associates findings. Also, the pace of spoken text in this study could not be controlled, and neither could be participants pause, rewind, and replay the spoken text. On the other hand, students with dyslexia who thrived in an academically intensive and text-heavy university environment. It is likely these students have developed strategies for learning with traditional tests and may no longer be described as disadvantaged relative to their reading performance. Our study expanded multimedia learning research by testing the modality principle and multimedia principle, comparing typical students with dyslexic students. So, does multimedia learning apply to different groups of learners in the same way? The answer will be definitely no. Although the findings from the study can inform the design of multimedia learning materials and improve the learning for these individuals with and without dyslexia, I think more studies should be conducted to further explore in this topic. While conducting this project, we also collected EEG data and eye-tracking data during the process. In the future, we may report that what we collected during including the EEG data and the eye-tracking data to support what we found. And compared with what Dr. Meyer has concluded, our study used content from social science. So in the future, we may use more intrinsically complex content and use more robust measures of learning. Representational images has been used in this study. Other types of images, for example, organizational image and transformational images, can also be applied in the interventions. And in this study, we suggest a future study that could inform the eventual design of adaptive and personalized multimedia learning solutions for learners with dyslexia. If you have any questions, feel free to email me. Here's the references. Thank you.